The last assumption is no multicollinearity. We observe multicollinearity when two or more variables have a high correlation. Let's exemplify this point with an equation. A is equal to 2 plus 5 times B. A and B are two variables with an exact linear combination. A can be represented using B, and B can be represented using A. In a model containing A and B, we would have perfect multicollinearity. This imposes a big problem to our regression model as the coefficients will be wrongly estimated. The reasoning is that if A can be represented using B, there is no point using both. We can just keep one of them. Alright, another example would be two variables C and D with a correlation of 90%. If we had a regression model using C and D, we would also have multicollinearity, although not perfect. Here, the assumption is still violated and poses a problem to our model. Usually, real-life examples are helpful, so let's provide one. There are two bars in the neighborhood, Bonkers and the Shakespeare Bar. We want to predict the market share of Bonkers. Most people living in the neighborhood drink only beer in the bars. So, a good approximation would be a model with three variables: the price of half a pint of beer at Bonkers, the price of a pint of beer at Bonkers, and the price of a pint of beer at Shakespeare's. This is logical, right? If one bar raises prices, people would simply switch bars, so the price in one bar is a predictor of the market share of the other bar. Alright, where's the problem? Half a pint of beer at Bonkers costs around $1, and one pint costs $1.90. Bonkers tries to gain market share by cutting its price to 90 cents. It cannot keep the price of one pint at $1.90 because people would just buy 2 times half a pint for $1.80. Bonkers management lowers the price of the pint of beer to $1.70. Next, we run a regression based on these three variables. The p-value for the pint of beer at Bonkers and half a pint at Bonkers show they are insignificant. Why? The underlying logic behind our model was so rigid. Well, no multicollinearity is an assumption of the calculations behind the regression. The price of half a pint and a full pint at Bonkers definitely moved together. This messed up the calculations of the computer, and it provided us with wrong estimates and wrong p-values. So, how do we fix it? There are three types of fixes. The first one is to drop one of the two variables. The second is to transform them into one variable. The third possibility is tricky. If you are super confident in your skills, you can keep them both, while treating them with extreme caution. The correct approach depends on the research at hand. Multicollinearity is a big problem, but is also the easiest to notice. Before creating the regression, find the correlation between each two pairs of independent variables, and you will know if a multicollinearity problem may arise. Thanks for watching.